Hello everyone, welcome to my channel. So today we are going to do one of the question of the blind 75 list. So here if you this is the list which we are following, and today we are going to do questions related to linked list. So we have already completed two of the questions, that is merge to sorted list and merge case sorted list, which is the hard level question, and this one the easy level question. But today we will be covering up with 1, 2, 3, 4. These 4 which are left in this linked list, that we will be covering today, and we'll get it done with the linked list part of this blind 75 list. So presently we'll go ahead and we will be starting with the detecting cycle in the linked list, means this particular question. So let us get started with the same. So here, linked list cycle. Given head, the head of a linked list, we need to determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuous following the next pointer. Internally, pause is used to denote the index of the node that tail's next pointer is connected to. Note that pause is not passed as the parameter. Return true if there is a cycle in the linked list, otherwise return false. So basically here in this question, whatever things are there which they themselves are checking that there is a linked list or not, those things are not passed as the parameter, but we are still required to check if there is a linked list just with the linked list head which is being provided to us. So for that purpose we would be required to follow one algorithm in which we will be detecting this linked list cycle, and we'll go ahead and just tell that there is linked list, thus we'll return true. If there is no linked list cycle, then we'll just return false. That is the thing. So now the part is, before implementing that particular algorithm, what we need to do and how we will be thinking without that algorithm, all those things we need to discuss. So first let us check for the constraint. So here if we see the number of nodes in the list is in the range 0 to 10 raised to power 4. That means if we go ahead with order of n solution, it will work. Order of n log n solution, that will also work. But order of n square solution, that won't work because this is 10 raised to power 4, and if we do n square, then it will become 10 raised to power 8. Then the values in the node. Anyhow, we will be comparing that this particular we'll see if we require values that much or not, but anyhow each will be having values and we don't require to do any multiplication or something like that. So here values won't matter that much, and pause is -1, or a valid index is in the linked list. Position -1. Okay, so basically they are saying the pause which is there, although they are telling that there is a cycle or not, so that they are telling. So it's like that pause is -1 or a valid index in the linked list. So the thing is that they are telling that at this particular position there is a cycle, but that pause is not passed, so we can't detect that there is a cycle if pause has some value apart from the -1. So that's the thing. So anyhow this particular thing is not that much help to us. What we require is that we are just given with this head, and we need to detect the cycle in the linked list is there or not. That is all. So this pause which is given to us, it is just for the part of like confusing us, nothing other than that. So follow, can you solve it in order of 1, that is constant memory? Okay, that is also one thing, because the thing is that the naive method which comes to our mind for the same would be that we would be using some extra space, some dummy nodes, and we will be storing all the nodes, and we'll check that have we reached that node again. If there would be a cycle, then surely we'll reach that node again, but if there is no cycle, then we won't be able to reach that node again. and in that context we will be using extra memory. But if we are going to optimize the solution by using that algorithm which we will be going ahead in this particular question, then that won't use any extra memory. So that's why they are saying that this is follow up and we need to do it in order of one memory. So now the first naive solution which we will be going ahead, means which we can think of, is we can use extra space. That particular would be, although in order of one solution only, we will be checking that while traversing the particular linked list and we will be storing the values of the nodes which are there. If in that particular unordered map or unordered set, if that is already existing, that value was already there, then that means there is a cycle. So anyhow, that will be order of order of n time complexity, and space complexity also order of n. But in this video I'll just code the optimized one. I'm just telling the brute force would be something like this, and its time complexity and space complexity would be order of n both. That would be the thing. So now let us go ahead with the optimized version, where we will be using order of one space, and there we will be using two pointers, and there the pointers which would be there, one would be the slow pointer and the other would be the fast pointer. So basically the things would be something like this, that the slow pointer which would be there, the 1 minute, something happened. The slow pointer which would be there and the fast pointer which would be there. So how slow and fast they are. So slow would be moving, slow equals 2, slow next, and the fast which would be moving, that would be moving 2 points ahead. So that's why they become slow and fast pointer. So the thing would be like, if we are having 1, 2, 3, say 4, and then we have a cycle here, right? So the slow pointer which is there, so the slow pointer and fast pointer, both of them would be at this point only, right? So when slow moves next here, now slow is there, the fast would be at this point. Now the slow would be here, but the fast pointer which would be there, that would be 1, right? And then we are having again, so okay, sorry, not this thing, anyhow, because there is one cycle, right? So it won't be moving ahead, it will be moving back towards that cycle itself. That would be the thing. So now fast would be at this particular point. Now when slow comes, now the next positions which would be there, so it moves one step ahead, right? And the fast will move 1 and 2 at this particular point. So now at this particular point, slow is at this point and fast is at this point, right? So now slow will be moving back towards the 2, right? And fast will be moving 1 and 2, right? Now anyhow, slow was at this particular point and slow will also come at this particular point. So slow and fast, both of them would be pointing to the same node, and that's where we will be able to detect that yeah, there is a cycle. If this was not the case, then anyhow you can clearly see that 1, 2, 3 and 4, slow will be moving here and the fast would be here, right? And then slow will be moving till here, but anyhow fast can't move. Fast will just completely exit out from the loop, because fast needs to move 2 points, right? And fast will be pointing towards null at this particular point, right? So that's why at that point only it will exit out, and fast and slow will never be equal, means never be pointing to the same thing. So that would be the scenario. So that's why here we can clearly see, if there is a cycle, they will meet. If there is not a cycle, they won't meet. And this is a thing which we are required to implement. Now here the possible edge cases which are there. One, you can clearly see this one. So it doesn't throw any runtime error. So in that context, we need to keep the edge cases in that manner that if fast is there or if fast next is there, then only we will be moving ahead, else we won't move ahead. And in this, the time complexity which would be there, that would be order of n as it is, but the space complexity, that would be order of 1 because we won't be using any extra space. So this was the explanation part for this particular question. Now comes the part that how we need to implement this. So let us go ahead and implement the same. So as I had explained that we will be going ahead with slow and fast pointer, so that only we will be going ahead. So we will take this note star the fast pointer that will be pointing to head, and same goes with the slow pointer that will be also pointing to the head, means both of them are pointing to the head at the starting. Now we will keep our conditions. Now the last time when I had explained, it was like or condition, but do you think that is right one? The thing is that is not right one. We are required that both of them should be true. If either of them is true, then also it will throw runtime error only. So that's why both fast and fast next should exist. Then only we will be moving ahead. So this condition we need to keep, and then we need to move our pointers. So slow would be slow next, and fast would be fast next and one more next, because this is the fast pointer. Now while doing all this, we will be also side by side only checking that if slow is equals to fast or not, because there would be some point when they will become equal if there is basically if there is a cycle. So at that point only we'll return true, that yeah, we detected a cycle, right? Else if it exits out from that particular loop, then we need to return false. And this was pretty much smaller simple code for detecting the cycle, and this is one of the standard code which is required to be done. Standard code, that means that this could be part of various other questions, but this is a smaller part which need to be done. So this was all for this particular video. If you have any doubt, or if you have like, yeah, this could have this solution also, something like that, you could comment that down. So yeah, this was all. Now let us run this and check if there are any compilation error or something. So here if we see all three are accepted, let us submit the same. So yeah, it got accepted. So yeah, this was all for this video. If you have any doubt, you could comment that down, and if you really like the explanation, you can like, subscribe and share this among your friends as well. So this was all. Thank you.